Ladies and gentlemen, welcome back to my YouTube channel. In today's class, we will embark on a fascinating journey to explore one of mysterious behaviors of lightning. Lightning discharge has long been a subject of wonder, and today, we will delve into its electrical behavior. Here is the question: which type of electric current is lightning discharge? This leads to questions like: 1. Is lightning discharge DC or AC? 2. If lightning discharge DC, what makes it DC? Or if it is AC, what makes it AC? Lastly, does it mean that it is both DC and AC? If it's so, what can we then classify it as? These questions raised curiosity among scholars, causing serious debate between DC or AC. Relax, we are going to unravel the complexities of lightning, and uncover why lightning cannot be confined to traditional electrical categories, and discover its unique characteristics that set it apart. So, by the end of this class, you will find out which current is lightning discharge, and why it is. Therefore, stay tuned as we start. Welcome back. Please, if you haven't supported this channel, you can do that by hitting the subscription button below, so that you will not miss any of my important classes. You can also drop your questions in comment section below. So, let us continue. Lightning is a natural electrostatic discharge that occurs between two electrically charged clouds, or between electrostatically charged clouds and the Earth. It is often accompanied by thunder. This is a brief explanation of what lightning discharge is. You can check out my video on it, through the link in description box below. It will give you proper insight of lightning discharge. Without delaying, let us proceed to today's topic, which says: is lightning alternating current AC or direct current DC? Let us begin from analyzing AC behavioral properties. First, alternating current AC is an electric current that periodically reverses direction, oscillating between positive and negative values. This means the current changes its direction, repeatedly at a specific frequency. Having understood what AC means, let us dive deeper into why lightning discharge cannot be classified as 100% AC. There are 4 key reasons that contributed to that. This includes the followings. Number 1. Non-periodic waveform. AC has a sinusoidal waveform that repeats at a fixed frequency. Lightning's waveform, on the other hand, is a complex, irregular pulse with rapid changes in current and voltage. This unpredictability and lack of repetition make it fundamentally different from AC. Number 2. No repeating cycles. AC involves repeated cycles of current reversal, typically at a fixed frequency like 50 or 60 Hz. Lightning discharge, however, is a single and brief event that does not repeat itself. It is a transient phenomenon that does not show the oscillatory behavior characteristic of AC. Because of this, it is not classified as 100% AC. Number 3. Wide range of frequency. Lightning discharge does not have a fixed frequency like AC does. Instead, it contains a wide range of frequencies, due to its rapid acceleration of charged particles and transient nature. This frequency spectrum can range from a few kilohertz to several gigahertz. On the other hand, AC typically operates at a single and fixed frequency of 50 or 60 Hz. This makes lightning discharge not to be considered as AC. Lastly, lightning discharge resembles a sudden short circuit that occurs either between clouds, or between clouds and the ground, primarily caused by a high concentration of electrical charge. It also behaves like a capacitive discharge, where current flows from the positively charged plate to the negatively charged plate in one direction, causing capacitor discharge. Because of this unidirectional flow of charge, lightning discharge cannot be considered AC. These differences we mentioned are the reasons why lightning discharge cannot be classified as AC. Since we have seen that lightning does not possess properties of AC in the right amount, let us now move on and check if it can be classified as a DC signal. Having done with AC, Direct current DC is an electric current that flows in one direction only, from positive to negative, without reversing or oscillating. The voltage remains constant, and the current flows steadily. Experimentally, for a signal to be considered DC, it usually must have a ripple factor below 3%, indicating only slight variations in its magnitude. Since you have know what DC signal is, let us quickly break down why lightning discharge cannot be classified as 100% direct current. These include the following reasons. Number 1. Brief duration. Direct current signifies a steady flow of electricity over a prolonged period. Lightning discharge, however, is a collection of events that lasts only microseconds. This transient nature opposes the steady-state characteristic of DC, thereby jeopardizing its DC properties. Number 2. Frequency of the signal. Direct current typically has zero frequency or a constant value, as it flows in one direction without oscillating or changing polarity. Whereas lightning discharge is transient in nature, with ranges of frequencies from kHz to 1 GHz. This behavior disrupts the standard of a DC signal. Number 3. High energy surge. Direct current typically involves a steady and one-directional flow of electricity. Lightning, on the other hand, releases an enormous amount of energy in a very short time, resulting in an intense high-power surge. This massive energy release does not fit the steady behavior of DC, because of predictable nature of DC, as it flows steadily. Lastly, complex waveform. Direct current is characterized by a smooth, constant flow of electricity. Whereas, waveform of lightning is complex and variable, with rapid changes in current and voltage. This complicated waveform is shaped by factors like the leader stroke, return stroke, and channel dynamics, making it far more complex than DC. So, this feature does not show properties of DC. These differences highlight why lightning discharge cannot be classified as pure DC. The unique characteristics of lightning, including its brief duration, high energy surge, and complex waveform, set it apart from the steady, predictable nature of DC. Since we have demonstrated that lightning does not possess either behavior of AC or DC signal 100%. What else is lightning, or what can we call it? Now, pay attention. Lightning is a transient impulse. This means that lightning is not purely AC, and not purely DC but rather a combination of both. In other words, lightning consists of both AC and DC surges. In conclusion, lightning discharge exhibits unique characteristics that distinguish it from both DC and AC. Instead, lightning is a transient impulse that has a double nature of both AC and DC behavior. Here, we bring to an end today's class. If you like this video, please support the channel by subscribing to the channel. Thank you for doing that, and I will see you in the next class. Bye for now.